Hi there. Welcome to Cats in the City, by Sith Sense. I'm Johnny.
And I'm Pearl.
Together, we would like to share with you pieces of interesting knowledge that we find.
And that could be useful to you in the future.
We'll build a simple game today. It's a number guessing game.
That's a very good idea. It's a good progression since we've learned function and loops.
Okay, let me explain the layout of the game. The user can choose either to be the game master or game player. Game master will pick a secret number while game player will try to guess the secret number, within the least number of guesses.
Wait, not so fast. We'll still need to go through a few things with our audience, before we can start building our game.
Sorry, I was too excited and got carried away. Firstly, you'll need to learn about module in Python.
There are many modules in Python, and that's actually one of Python's strength, compared to other programming languages.
A module is like a container that holds a set of related functions and variables that can be used in a program. Think of it like a toolbox that contains many different tools, each designed to perform a specific task.
Just as you can select the right tool for the job from a toolbox, you can import a module into your Python program to access the functions and variables it contains.
For example, Python comes with a built-in module called math that contains functions for performing mathematical operations like square roots, logarithms, and trigonometry. By importing the math module into your program, you can use these functions without having to write the code for them yourself.
And for our game today, we'll need to import a module called random.
To import the module, you simply write, import random, like this. It's very easy.
Before that, you'll also need to learn about if statement.
If statement is used to make decision in a program. It allows the program to check a condition and perform a specific action based on whether that condition is true or false.
Yes, you can think of it like a fork in the road. You can choose to go one way if a certain condition is true, or another way if it's false.
In Python, we use comparison operators to determine whether a certain condition is true. These operators are similar to their mathematical counterparts. As we mentioned earlier, Python is a high-level programming language that uses a syntax resembling both mathematical equations and the English language. This is one of the ways in which Python stands out from other programming languages. Its syntax is natural and straightforward, making it easier to read and understand.
Let's look at the syntax for the if statement. Our first example uses an if-else statement. Can you read the statement as if you are reading an English sentence?
Sure. My pet is cat. Your pet is dog. If my pet is equal to your pet, print, both of us like cat. Else, print we have different kind of pet.
Notice that a simple equal sign is actually an assignment operator, whereas a double equal sign is a comparison operator. You should always use the double equal sign instead of the simple equal sign in an if statement. Many new programmers make this mistake.
And also, don't forget to put the colon at the end of the first line in an if statement.
And the indentation on the second line.
Else clause starts on its on line, without the indentation, even though it's actually part of the if statement block. Else clause is simply that, else and colon, without any condition or expression.
In this second example, it's an if-else statement. If actually stands for else if. If your if statement has many conditions, you should use if clause for each condition.
My run is 5, your run is 10. If my run is equal to your run, print, both of us are in the same run category. Else if, my run is greater than your run, print, I am in the longer run category than yours. Else, print, you are in the longer run category than I am.
The else clause will handle the case where your running category is greater than mine. It's important to note that in Python, the if and else clauses are not compulsory in an if statement. An if statement can stand on its own and still perform conditional checks based on the given condition.
In an interactive game, we'll ask the user for input. In Python, it's very straightforward, you just have to use the input function.
When you call the input function, you type a question as parameter for the function. The user will see a dialog box, waiting for input. You should assign the returned input to a variable. This way, you can use the user's input in your program, as shown in our next example.
My age is 14. Question is, how old are you? The variable your age is assigned the value from the user's input. Next we'll check if my age is equal to your age, print, f string, both of us are my age years old. Else if my age is greater than your age, print, I am older than you are. Else, you are older than I am.
This is a very simple code, it looks fine, but there's a mistake in the code.
If you run the code, you will get a type error that says the comparison operator, is greater than, is not supported between instances of integer and string. Basically, the error is telling you that, you cannot use the comparison operator, is greater than, to compare an integer to a string.
The reason for this error is that the input function always returns user input as a string, regardless of whether the user enters an integer or another type of value. Therefore, even if the user enters an integer, it will still be returned as a string type.
To overcome this error, we can cast the returned input as an integer, like so.
Yes, doing this will solve the error, but it's not the best practice. Let's say the user mistakenly keys in a text, you will get a value error instead, because you cannot cast a string as an integer.
The best practice is actually to check the validity of the user's input. We can do this easily with a custom function.
Instead of going through another example, let's jump right into our game. I'm confident that, at this point, our audience can follow the code without much difficulty.
Okay. Firstly, let's go over the layout of our game. It's a number guessing game, and the user can choose to become either the game master that will decide the secret number, or the game player that will guess the secret number.
In the beginning, we'll let the user sets the upper limit for the secret number. Let's say the user sets the upper limit to be 100, then the secret number can be any number between 0 and 100, including the number 0 and 100 as well.
The game player will guess the secret number. If the guess is correct, the game ends, but if the guess is wrong, the player will be given a clue. The clue will inform the player whether the secret number is greater than or less than the guessed number.
When the game ends, it will ask the user whether to continue playing a new game. If the user chose to discontinue, the game ends completely. On the other hand, if the user chose to continue playing, the game will start anew.
And that's the layout of our game. So firstly, we should import the random module. We'll need the random module to generate the secret number and also the guesses.
At the beginning of our game, we'll tell our user the role of game master and game player. We can simply print a statement for each.
Then, we'll ask whether the user wants to be the game master. Remember, as the best practice, we must verify every input from the user. So, instead of using the built-in input function, we'll create a custom function ourselves.
Let's define our function as valid string input, with one parameter f. We'll use a while loop for this function. Remember the for loop? Similar to a for loop, a while loop is a type of control flow statement that allows you to repeat a set of instructions multiple times.
However, while loops operate differently than for loops in terms of their syntax and the way they control the flow of a program. Let's look at our while loop.
Firstly, we'll need to create a condition. This is its main difference from the for loop. In our while loop, we first assume that the input not valid is true, and because the condition is true, the while loop will execute its code.
Now, we'll use the input function in our custom function. In our case, we'll ask our user, do you want to be the game master? Yes or no? Y for yes, and N for no. This question is passed as parameter f into our function.
Then, we create a list that contains all the valid string input. There are only two valid string from user, either N or Y. We assign the list containing N and Y to variable valid string.
Remember that in Python, string is case sensitive. An uppercase Y is different from a lowercase y. We wouldn't know whether the user will input an uppercase or a lowercase letter. So we use the string method called lower. The lower function will convert the input into lowercase letter, so that it's comparable to our valid string list.
Our if statement will check whether the user input, converted to lowercase, is a valid string. If it is valid, the function will return the user input in lowercase. Otherwise, it will print an error message requesting valid input. The while loop will keep prompting the user for input until a valid input is received. Once a valid input is received, the function will execute the return keyword, indicating that it has completed its task and causing the while loop to terminate.
Remember that, in a while loop, the loop continues executing, as long as the condition specified in the while statement is true. New programmers sometimes make the mistake of writing an infinite while loop, because they forgot to code the condition that will stop the while loop.
Next, we'll ask the user to set the upper limit for the secret number. We'll create a function called setUpperLimit.
We should also verify the user's input here. However, the valid string input function verifies string input only, so we need a new function to verify integer input.
We'll call the function valid integer input with one parameter f. It's very similar to valid string input, with the while loop.
To handle string input, we first convert the string to lowercase to avoid any case sensitivity issues. When dealing with integer input, we utilize the string method isDigit to check if the input consists of only numerical characters. This function returns true only if all characters in the string are digits, treating any non-digit characters like a negative sign or decimal point as non-digit. This behavior aligns perfectly with our intended use case.
If the user's input is valid, then the function will return the input cast as an integer. Otherwise, it will print an error message requesting a valid input. Similarly, the while loop will keep prompting the user for valid input. We'll set the upper limit as x.
After receiving these two inputs from our user, we proceed to the next step in our game. If the user chose to be the game master, then we'll run the game master function. Otherwise, if the user chose to be the game player function will be used.
Both of these functions are quite complicated, we'll go through them later.
After the game has stopped, we'll ask the user whether to continue playing. We'll reuse the valid string input function to verify the user's input.
If the user replied no, then the game will print a goodbye statement. However, if the user replied yes, then the game will start anew.
Restarting the game is a behavior that we can code using another while loop. As usual for a while loop, we create a condition for the while loop. We can use variable called continuePlaying and set it to be true.
The whole layout for our game should be moved into this while loop, like so.
Let's return to the last user's input. So now, when the user replied no, we need to set the variable continuePlaying to false. Conversely, the variable continuePlaying remains as true if the user replied yes.
Now we are done with the overall layout of our game, let's move on to the game player function.
Yes, let's do that.
Remember that the game player function is called when our user decides to be the player. So, the computer will be the game master and choose a secret number.
To choose a secret number, we can use the random module that we have imported at the beginning of our code. In the random module, there's a function called randint, short for random integer. Its syntax is random.randint a to b. It will return a random integer greater or equal to a and less or equal to b.
In our game, the secret number must be greater or equal to 0, whereas our user has set the upper limit to x. We can pass x as the parameter for our function.
So now, the secret number has been chosen as a random number between 0 and x. Remember, both the number 0 and value of x is included.
The player will keep guessing until the guess is equal to the secret number. This calls for the use of a while loop. As usual for the while loop, we need to create a condition for it to run. We can use while user guess is not equal to secret number. The operator, ! And equal sign, means is not equal to.
We set the initial value for user guess as -1 because -1 is beyond the range of our secret number. In other words, our secret number will never be equal to -1. We'll also use another variable called count of attempt. This variable will be used to keep track of the number of guessing attempts. Initially, we'll set it to 0.
We'll ask the user to guess the secret number, and we'll store the user's input as the new value for user guess.
Notice that, we reuse the valid integer input function here.
After that, we'll use an if statement. If the user guess is greater than the secret number, we'll print the clue the secret number is smaller than user guess. Vice versa, if the user guess is smaller than the secret number, the clue, the secret number is larger than user guess will be printed.
The if statement in our code is executed only when the user's guess does not match the secret number. You may have noticed that we didn't explicitly handle the case where the guess matches the secret number in the if statement. However, this scenario is already covered by the while loop condition. If the user guess matches the secret number, the while loop won't execute, and the if statement won't be evaluated. Therefore, there's no need to include an explicit condition for this case in our if statement.
In addition, we incorporated the count of attempt inside the while loop to keep track of the number of guesses made by the user. The += operator is a shorthand notation for incrementing a variable by a given value. For instance, the expression a + = 1 is equivalent to a = a + 1. We utilized this shorthand notation to update the count of attempts each time the user guesses the secret number.
So, if the user guessed the secret number correctly, the while loop will not execute and the user wins the game. We'll also tell the user the number of attempts before they succeeded in guessing the secret number correctly.
Next, we'll move on to the game master function. Remember that, if the user decided to be the game master, the user will choose the secret number, while the computer will be the player that guesses the secret number.
We'll need to set the lower and upper limit of the guesses. Let's use A and B. Initially, A will be 0 and B will be X, which is the upper limit for the secret number. A and B will be updated from the clues given by the user, who is the game master.
We'll initiate the while loop similarly by assigning the variable guess incorrect to true and the variable count of attempt to 0. The computer will make a guess using the randint function, with A and B as its parameters.
The computer will convey its guess through a print statement. Then, the user will give feedback whether the guess is too high, too low, or correct. We can reuse the function valid string input to verify user feedback.
Previously, we set the list of valid string as N and Y only. But now, the valid input could be H, L, and C. We'll need to modify our function for this.
It's actually quite easy. We'll just pass an additional parameter g to our function. This second parameter g can take two values only, either play or guess.
We'll also add an if statement inside the function, like this. So, if g is equal to guess, the list of valid string contains C, H, and L.
On the other hand, if g is equal to play, the list of valid string will contain N and Y only.
Remember to update every instances where the valid string input function is used, with the additional parameter.
I'll use an example to explain the following code. Let's say the secret number is 55, the lower limit is A and the upper limit is B, both initialized to 0 and 100 respectively.
When the computer guesses 70 and the user replies too high, we know that 70 is not the correct answer and the secret number can only be between 0 and 69, inclusive. Therefore, we update the value of B to 70-1, which is equal to 69.
On the other hand, if the computer continues and guesses 40, and the user replies too low, we know that 40 is not the correct answer and the secret number can only be between 41 and 69, inclusive. Therefore, we update the value of A to 40 plus 1, which is equal to 41.
This process of narrowing down the possible range of the secret number continues until the correct number is guessed. In that case, we'll have to change the variable guess incorrect to true, and thus stopping the while loop.
This process of logical deduction is what gives the game the appearance of intelligence. However, it is important to remember that the game is only as smart as the code that has been written. Therefore, programmers should strive to write more efficient code with better logic and reasoning to improve the performance of the game.
Yes, I agree with you 100%. The good news is that there are many resources available that we can use to improve our coding skills. Additionally, real-life experiences, even if they are unrelated to coding, can indirectly help us improve how we write code.
And there's another piece of good news.
Really? What is it?
We have finished building our game.
Hooray! Let's play the game.
Sorry, Pearl. Our code is quite long and so is our video. I don't think our audience wants to watch us playing this game.
Yeah, I got carried away. But you should definitely play the game, once you have finished building it. It's a good way to check your program for bugs.
To make it easier for our audience, I'll put the link to the Colab notebook in the description below. You will be able to view the code but you won't be allowed to make any changes to it. However, you can copy it to your own notebook.
The sense of pride that you feel when you play a game that you've built for the first time can be a great motivator for learning and building better programs. Personally, I remember feeling extremely proud when I played the game that I had built for the first time.
This time, I would like to challenge our audience to revise and improve our code. There's a major bug hidden within the code.
The bug was caused by the fact that we relied entirely on the fact that our user is honest when giving feedbacks. What if our user lies about the clue to the secret number? If this happened, our game will crash and the user will receive an error message. Try it for yourself.
Maybe our user made an honest mistake. Let's say the secret number is 25 and the computer guessed 18. Our user, who's the game master, mistakenly announced that 18 is too high. So now, there will be a logical error in our code.
And the challenge is, how do you overcome this bug?
You can also improve the game and make it more challenging by setting a limit to the number of guessing attempts. Let's say the number of attempts should not exceed 10 times, the while loop will break when the variable count of attempt reaches 10.
That's an interesting problem, and how will you solve that problem? Tips: you can use another if statement, which is easier, or you can modify the condition for the while loop, using a logical operator, and this is a more advanced solution. Hey, you can even just use a for loop. There are so many solutions to this problem.
That's all from us this time. I'm Johnny.
And I'm Pearl.
Bringing you bits and pieces of interesting knowledge from cats in the city.
Thanks and see you next time.